Active Directory Introduction. In this nugget, we introduce Active Directory, and it kind of lays the groundwork for the rest of our nuggets, where we'll get kind of a definition of terms, a common understanding of some of the technologies that are involved, and we'll also understand many of the features of Active Directory, as well as some of the files that are involved. Active Directory is actually stored in a single file, and there are several other helper files that might be useful to know about. We'll also take a look at the Active Directory structure. I mean, what really is a domain? What's a tree? What's a forest? We'll also take a look at what an organizational unit is and some introductory looks at how it might be able to benefit you, as well as what a site is. Alright then, what is this thing called Active Directory? I mean, it sounds pretty cool, Active Directory. Well, is it really any different than any other kind of directory? I mean, Microsoft does not have a corner on the market with any kind of directory. You've got Novell, which has Novell Directory Services, or NDS. You have various other kinds of directories. What is it about Active Directory that's so magical? Well, first of all, it's just magical in that it's a good marketing term. I mean, active, it's not any more active than any other directory service that you might find out there. It's just that it sounds kind of cool to say Active Directory. Oh, what else does it have, though? Well, let's talk about some of the benefits that we actually have with Active Directory and what it really is. Active Directory is going to give us the ability to store things such as users, groups, computers, file shares, things like that, within Active Directory. And if I go to the Start menu and go to Administrative Tools here, you'll see that you'll be able to go to Active Directory Users and Computers. And there's several other tools that are also available to use with Active Directory and which contain Active Directory data, such as domains and trusts, sites and services, and users and computers. Probably we'll be seeing users and computers the most frequently, however, and here's where we're going to see things such as the actual user accounts, the group accounts that we have, any computer accounts that we actually have, any domain controllers that we actually have. All of those things are going to be viewable within Active Directory Users and Computers, and again, that's where we mostly will see Active Directory data. Well, it's tools like Active Directory Users and Computers that allow us to have some of these Active Directory features. Now, one of the big ones there is that we have a centralized data store. Now, the way to really understand that is I just think of my wife when I think of this, because, you see, my wife is not technically savvy. She's very smart, very organized, but she's not technically savvy. So I went up there the other day and I said, hey, I need an email address for a certain someone. And she said, okay, and she's looking through Post-it notes and through all these different papers on her desk, and she's looking through yellow legal pads. And I see her looking through all this paper, and I say, hey, you know, I set up Microsoft Outlook for you. There's supposed to be a contact list there. Why don't you just look there? She goes, oh, well, I never use that. Well, great. I guess it's a typical story of the cobbler's children have no shoes. My own family doesn't even use the technology that I teach. Anyway, so I have to take a look at that, and I understand that some people don't centralize their data stores. Like my wife doesn't centralize all of her contacts. Well, that might be the case also in something like a mixed network here. For example, if we use the worst case scenario, and yeah, you'll see that there are better solutions than this, but I'm just saying the worst that could happen. Here we'd have a user at a workstation that's on an NT 4.0 network, and they log on using their username and password to log on to the NT4 domain, and they get basic access to the network. Well, then they need to access a Novell Network application, which uses different credentials, so they have to log on again. Then they need to access a database using another set of credentials, because this is a third-party database that has no relationship to NDS or NT4. So there's their third logon. Then they need to access a file share over on this Unix file share over here. And it's going to have a different set of directory database, so it's going to have a different set of user credentials. And then they need to check their email on this application here, and they're logging on again. Then they dial in from home, they're logging on to the RAS server. So they got separate credentials all the way around. They might have, in a worst case scenario, at least 6 different set of credentials that they have to remember. Different username perhaps for each one, different password for each one. And then you have another situation. What if the password length, or the password duration for this NT4 domain controller expires the passwords after 42 days. But in NDS, it expires after 30 days. And here in this database, it expires after 15 days. Then we got 5 days over here. That's pretty low. But anyway, we got 5 days there. We got, 60 days here, 90 days here. So you got all different kinds of expirations going on here for the number of days that expire before the password expires. Well, that, of course, presents another problem, because when I change my password on this NDS server, then if I'm trying to keep the same password on all of these servers, then I have to find out a way to change it on all of these other servers as well. You can see where this just gets to be real sloppy real fast. So what we could do instead is to go to a Microsoft solution here, where we'd have not a mixed network. In this case, what if we went to all Windows Server 2003? And of course, this is going to look like a Microsoft commercial, and maybe it is. I mean, that's how I make my living on Microsoft products. But anyway, it does work. And there are other solutions that work equally as well, whether you like Linux products or whether you like Novell products. This is one example of how we can centralize our data store. So now I've got a Windows Server 2003 domain controller here, and I've got some redundancy so that after I log on, if this domain controller fails, I still have another domain controller that can also process my logon. Also, I've got a Microsoft SQL Server that can use the same accounts database that come out of these domain controllers for access to this SQL database. When I dial into my RAS server, it also checks with my domain controller over a secured channel to check to see whether people that are logging on have an authentic username and password. I can use Exchange Server 2003 as well. And it also uses the same centralized data store of my user accounts up here to be able to check credentials for people that should or should not be able to access email. In fact, Exchange is so integrated with Active Directory that I can actually create my user accounts on my Exchange server. I don't even have to use my domain controllers here. I have the tools available to create a user account here and to set up a mailbox for them all at once on Exchange. Then I've got here my Windows Server 2003 file server. Again, it used this centralized data store on my domain controller to check those users' credentials. So now I only have one set of username and password, and I have one password policy that determines how long and how complex the password has to be and how often it has to be changed. So again, the fact that it's centralized is such a great feature for it. Now you might be playing the devil's advocate here and saying, well, you know, James, with that first diagram you showed us where we had NDS and Unix and all that stuff, you know, there's all kinds of tools you can use to synchronize the passwords between all of those various operating systems and to make it all work together. Yeah, that is true, but that also makes my point for me. You see, you have to trick it into working together. With Microsoft's own solution with Windows Server 2003, it's already centralized. You don't have to trick it to work together. It just does. Also, Active Directory is scalable, meaning that we can make it pretty much as large as we need it to be. I mean, they're very large corporations with tens of thousands of users and computers that have not broken Active Directory because it's gotten too big. In fact, even in labs, some friends of mine have gone and tried this. They've created millions of user accounts, millions of computer accounts, and have still not broken Active Directory or made it perform in such a way that was unacceptable. So you can create a gigantic Active Directory database, and it is scalable. The only problem we ran into is if you run into a hard disk that doesn't have enough space left to store additional records, then of course you're going to have a problem. Then we also have an extensible database, and this means that I can make modifications to the kinds of data that are stored here. For example, what we have in Active Directory are Active Directory objects. For example, this user account, the trainer account, which is the administrator capable account that I use to log on, as you can see here, this is an Active Directory object. A group like the domain users here, that's an Active Directory object. Any computer accounts, any domain controllers I have in here as well. These are all Active Directory objects, and as such, they also have attributes. The attributes are more specific information about the Active Directory object. So if I double click on the trainer account, or I can also right click on it and choose properties, brings up the same dialog box here, then this shows me the specific attributes about this user account object. For example, the first name is an attribute, last name is an attribute, description is an attribute. All those things are attributes. Well, what makes it extensible then? You see, I can add additional things into this. So the fact that this is extensible can allow me to add additional information in here. For example, if I clicked through all of these things, we wouldn't see anything that included information about an employee ID number, or an employee ID badge number, or a social security number. If we needed to include that information in there, then I could add in an additional attribute into this user account. Now, doing something like that, which is what we would call extending the schema, and the schema is what defines what different fields or different attributes you can have within this thing, and it's kind of the skeleton off of which you hang all of these trainer account properties or any other user account properties. Well, we can modify the schema to add additional information like that in there if we wanted to. You might also consider something like maybe you'd want a picture of the employee right here, and you just put in a GIF file there that has a picture of that employee, and then you can make this work in conjunction with maybe third-party software, which would print out employee ID badges. So that it would automatically draw from the first name here and the last name here, and then it would also pull out this picture that's in this user account properties and send it to the employee ID badge printer and spit out an employee ID badge for you with all that information already on it. So the flexibility and the extensibility of Active Directory really allows us to work very well potentially also with third-party applications that might be designed to do custom features for us. We also have great manageability with Active Directory, and that really comes in handy in things such as delegation. You see, if you're coming from an NT4 environment, let's say you have a user account there that you want to be able to be kind of a junior admin. You want them to be able to create accounts, so you add them to the account operators group. And you may also want them to perform certain other administrative functions, but there's no real group that allows you to do that. So you find yourself being forced to add that person to the domain admins group. Well, you don't really want them to have that much power. You want them to be somewhere in between there. Well, with Active Directory, you can do that because you have something called delegation. And if there's not a security group that allows you to do what you want, then you can just use delegated administration. And that means that I can control exactly how much power a particular user has. Maybe I only want someone to be able to change the phone numbers in any given user account. Well, I can be that granular and only give them that level of control. Or I might say, I only want this person in this department to be able to reset users' passwords in case they can't find anyone at the help desk or something. Again, you can be that granular in the kinds of control you allow people to have. A big step over something like NT4. Of course, we already also had all of these things as well in Windows 2000. We also have DNS integration. Now, DNS is tried and true for years and years now on the internet and through other operating systems. Microsoft has used it for a long time, but starting with Active Directory in Windows 2000, it's integrated with Active Directory. So now, if I create a zone, and I've got one here already, and we're not really discussing DNS much in this topic, but if I just go to DNS in my administrative tools, and I look at my forward lookup zones where I've got nuggetlab.com, this, in any other DNS database, would just probably be a standard text file, and you could crack it open in Notepad if you wanted to. In this case, all of this stuff is actually in Active Directory, and the advantage of that is I can replicate this to other DNS servers that are also domain controllers and have redundant copies of all of this zone data, and it's all read-write zone data. So the DNS integration is excellent. Another thing that we have there is that it's necessary because you have to have DNS in order to have Active Directory. And the reason for that is, when someone, for example, wants to log on, what they do is they actually, in the background, go to DNS to find a domain controller. And the domain controller located through DNS will direct that particular computer to a domain controller so that they can log on. And it really all starts with the computer looking for a domain controller because computers are users in Active Directory and computers actually log on. It doesn't require anything on your part, but the computer logs on, and then once the computer logs on and you have the Control-Alt-Delete dialog box for you to log on as well, well then you'll log on to the same domain controller that the computer used to log on that it found for you. We also have group policy objects in Active Directory. I think this is possibly the single most powerful feature of Active Directory in terms of practical administration, because you can control virtually every aspect of anything that the user can do and that the computer can do as well. And this has far-reaching capabilities in terms of the kind of security that you provide for your network and the kinds of capabilities that you provide the users on their desktops and what they can see and what they can't see and what their capabilities are. We already had this in Windows 2000 like all these other features as well. However, it's only gotten better in Windows Server 2003. And the advantage of a group policy object is I can configure a setting in one little place in Active Directory and have it apply to, if I want to, my entire domain. I might be able to affect thousands of users at one time with that one little checkbox or with that one little setting in a group policy object. And we'll look more at policies as we go throughout this series. Let's also take a look at a couple of other Active Directory features, and probably one of the strongest ones there is going to be security, because there's authentication that takes place when the computers log on and when the users log on that validate that you are indeed who you say you are, and it's also mutual authentication so that we can confirm that we're logging on to an authentic domain controller, not logging on to some imposter that's trying to collect our credentials. What it primarily uses for user and computer logons is a Kerberos version 5 logon. And Kerberos is not new with Microsoft. It was really developed at Massachusetts Institute of Technology, or MIT. And it so far has not been directly cracked in its current implementation, so it's very secure. You can also use other kinds of authentication depending on your purposes. For example, if you had a secure website for your intranet that you wanted employees to be able to look at their employee benefits or some other private information on their secure web, then you can use HTTPS web pages or secure socket layer web pages, and that can work in conjunction with Active Directory. So you've got SSL available for you as well. You've also got certificates that you can use. So for example, if I have a wireless network and I want to make sure that the computers that can access my wireless network have a valid certificate, I can do that as well, and that also interoperates with Active Directory. And that would then prevent me from allowing just anybody who happens to drive by my building to suddenly get free network access, free internet access, and free access onto my network, because they'd have to have a valid certificate. Now, after we've properly authenticated on the network and proven that we are indeed who we say we are, then we need to access resources on the network, and that's going to require something called authorization, where we can see whether or not, yeah, I am who I say I am, but can I access that resource I'm trying to access? So if I double-click on a shared folder on the network somewhere, that's supposed to be a folder. It looks kind of like a boot, I know, but it's supposed to be a folder there. I need to make sure that I have the proper ACL on that. So let's take a look at an example, and we're not going to get too much into file permissions right now, but I do want to go to the properties of just any old folder here, and I'll go to the security tab, and we see, for example, that we have administrators, creator, owners, system users. I have to be a member of one of these groups in order to access this specific folder. And if I'm just a generic user, then I see that I only have read and execute, list folder contents, and read access. So I could not, for example, add additional files to it or make changes to this particular resource. Well, when I try to double click on that folder, I have to be authorized, and so it can see what level of permission I have to be able to touch that folder, whether I can make changes, whether I can just read it, and so forth. And it uses what we call ticket granting tickets to be able to perform that authorization. The ticket granting tickets are part of the Kerberos version 5 authentication that we used earlier. And the users and groups that are in the access control list come out of Active Directory. Now, LDAP traffic is also going to be secure. LDAP is Lightweight Directory Access Protocol, and it's a subset of a larger standard called the X.500 standard. X.500 is a little bit too large and cumbersome and complex to be of practical use in most situations, so Microsoft opted to use this standard instead. And this is not a Microsoft invention. This is another standard out there, and it's more than sufficient for Active Directory. In any case, the LDAP traffic itself is also going to be signed. That means that when I have maybe a file server and a domain controller communicating with one another and passing back and forth some kind of a authentication attempt or an authorization, then that traffic, and that LDAP traffic, is going to be signed, meaning that it can be proven that it's not been tampered with in transit and that it is indeed coming from the computer that it says it's coming from. Another advantage I have is a very efficient replication mechanism, because you should have more than one domain controller in your environment. Let's just say that we've got 3 domain controllers in this site. Well, what happens is if I have a change in the directory database on this domain controller, and that's where the domain administrator made a change, maybe they added a user account here. It's supposed to be a person. They may added a user account there. Well, within just a few minutes, it's going to be replicated down to this domain controller. And the efficiency of this is it only replicates the changes. So it doesn't replicate the entire directory database. This might be, 400 or 500 megabytes in size of Active Directory. Well, it doesn't replicate all 500 megabytes, just this one little user account, which is probably a few K in size. And now within about 5 minutes, I've got that user account down here as well. So that if this new user is attempting to log on, they'll be able to log on to either this domain controller or to this domain controller. And within another 5 minutes, I might have it over here on this domain controller as well. So the replication is very efficient in terms of our network traffic, and it's pretty timely in terms of how soon it comes to convergence, or whether each one of these domain controllers all agree with what the directory database looks like. Let me also take a quick tangent here and point out another advantage of this. Let's compare this to an NT4 environment. With NT4, you may recall, if you worked with that, you had a PDC, or a primary domain controller, which was the only read-write copy of the directory database. That means that this is the only place that I can actually create a new user account. Now, I would also have other domain controllers that could process logons. These would be known as backup domain controllers. And these backup domain controllers here, I might have multiple backup domain controllers, but they're only read copies of the database. There's only one PDC, which is the read-write copy of the database. And if this one fails, then I have no way of creating new user accounts. I have to kind of jump through hoops to get this backup domain controller to be promoted to a PDC, and you got to do all kinds of things with this. Well, in Windows Server 2003, we don't have that scenario anymore, because we don't have a PDC and a BDC kind of an environment. Instead, each one of the domain controllers in Windows Server 2003 or Windows 2000 are all read-write copies of the database, and I can create new accounts on any one of these domain controllers, or modify or delete accounts. And again, within our timely replication schedule, that change will be replicated around to our other domain controllers as well in a timely fashion. Well, Active Directory is actually also going to be stored somewhere, doesn't it? I mean, isn't there a file that actually contains all of this stuff? Sure there is. And if you take a look at your system drive and your system directory, which in my case is C:\Windows, then you go to another subdirectory called NTDS. And here's where all the good stuff is. First of all, let's look at this file, NTDS, or ntdirectoryservice.dit. DIT is directory information tree, and that comes from its x.500 roots. That is Active Directory. Now, it's not like I can crack it open in Notepad and look at all the contents of that and everything like that. I can't even copy it or paste it because it's a locked file by Active Directory and by the system. And there are other better methods for backing it up, namely system state backup using NT backup. In any case, this is where the actual data itself is stored. Now, I've only created one account, and yet this is a 12 megabyte DIT file. Of course, there's padding in there. Microsoft has taken great lengths to make sure that they don't run up against the end of a file space, so that they don't make this exactly the same size that's needed. They reserve a little bit of extra space in there so that it is easily written to and read from. Now, when I create a user account or do something else to Active Directory, it does not immediately make the change directly into this DIT file. Instead, what it first does is it writes to a transaction log, and this is it right here, edb.log. And the reason why it writes to this log file first is twofold. Number one, it's for performance, because it will write it to the log file, and it will store that new record, let's say, maybe I created a new user account. It'll store that new object in memory. And then when this processor utilization calms down and it's at a period where it's a little bit less busy, then it will flush that information out of RAM and directly then, at that point, into the ntds.dit file, at which point it also removes it from the edb.log file. Now, there's also files that are used to check this all along the way, and that's this edb.check file. That's a checkpoint file that processes this throughout the entire procedure, from the time that I create that new user object to the time that it goes to the log file and into memory to the time that it finally gets flushed out to DIT. This accounts for the possibility that an interruption could potentially happen. And if in the midst of a transaction, while I was trying to flush something to the disk into the ntds.dit file, if there was a problem that occurred, the power went out or whatever, this edb.checkpoint file should be able to track that exactly. And if that account was only partially written, then it will be considered to have not been written at all, basically. And what will happen at that point is it will still retain whatever was in the log file, because even if the power's gone out, well, of course, that'll mean that my memory is drained, so it will not be able to flush it out from memory at all. But it will be able to still have that record in the log file, and at the next available opportunity, it can still flush it from the log file to the DIT file based upon where in the transaction the checkpoint file says it was. Now, there's also another file which we don't see here, but which may appear on your systems, especially if you have a very busy Active Directory. And that will be a file called edb, followed by a series of numbers.log. And those series of numbers are going to be hex numbers that are sequential numbers. The purpose of that particular file will be that it kind of is an overflow file. So if this log file has more than 10 megabytes, and that's how big this file will always be, it does not grow or shrink. If this file has more than 10 megabytes worth of data to write out, but it hasn't had a chance to write it out to the ntds.dit file, what it'll do is it'll create an additional edb and then the hex number.log file to hold the overflow. Then we also have a couple of other files here, res1 and res2.log. Chances are you'll never ever use these 10 megabyte files. The only purpose for them is so that if you start to run out of spindle and you're really low on hard disk space, and there's not any longer enough space to grow the ntds.dit file to the appropriate size, then it reserves 10 plus 10 is 20 megabytes worth of space for any Active Directory changes or modifications or additions, and it holds them in these log files until you can upgrade your hard disk. But of course, it would be judicious for any administrator to watch your hard disk space carefully and never let it get to the point where you've only got 10 or 20 megabytes worth of disk space left. And this is 10 megabytes each for these, and that is reserved space that cannot be overwritten by anything else in the file system. Now, before we get too far along with what Active Directory is, let's take a look at the actual structure of Active Directory. And this also defines what the contents of Active Directory are. All the contents of Active Directory are stored within this core component of Active Directory, and that is the domain. This contains my users, groups, computers, organizational units. It's where I will define certain things such as sites. It's also what comprises the structure for a tree or a forest, and we'll look at all of those things as well as we go along. Now again, the best way to understand a domain is to actually look at it graphically, and that's going to be best represented by Active Directory users and computers. So again, here's all my important items within Active Directory, my user accounts, group accounts, computer accounts, domain controllers, and the like. Now, once I've created my domain, I can then create an organizational unit within that domain. And the purpose for an organizational unit is for many things, really. The primary purpose is to make administration easier for the IT department. It's not for the users themselves. In fact, the users probably don't even know what OU they belong to. Instead, the advantage of an OU is for administrators, and I can do things like add specific users, groups, or computers into an OU, and then I might have a specific security group that I want to delegate control to that OU. For example, I might have a help desk security group, and I'll delegate control, and we'll look at that in specific detail later on in this series. And then whoever's a member of that help desk organization or help desk security group will be able to manage that OU. And I can also use that organizational unit to configure group policy objects so that I can specify exactly what the desktop looks like for those users, security settings for those computers, and so forth. And that might be a little bit different from one OU to the next. And it gives me, therefore, more granular control over that OU. Now, if I branch out to include multiple domains in my structure, then I might wind up with something like this. I might have at the root of my namespace nuggetlab.com. But I might decide that I need to also have a child domain for North America. So when I create a domain controller for NorthAmerica.nuggetlab.com, in the wizard, which we'll see in our next nugget, in the wizard I'm going to tell it that I want it to join an existing domain tree here, an existing forest. And in that case, what's going to happen is it's going to create a two-way intrinsic trust relationship here. So that a user up in this domain, for example, might be able to print to, say, a printer down here in this domain for which they've been granted access. Conversely, a user down in this domain here might be able to access a folder for which they've been granted access up here. And we have a two-way trust relationship so that we can access resources in both locations. Notice also that both of these domains in a tree relationship share the same namespace. They both share nuggetlab.com, and it's just hierarchical. I've added another level here at NorthAmerica.nuggetlab.com. Now, I might also create another domain over here, and when I use the Active Directory installation wizard, which we'll take a look at in our next nugget, it's going to ask me if I want to join an existing forest. And if I do, then I'll tell it that I want it to join nuggetlab.com's forest. And in that case, we'll have two separate namespaces here, and yet they're going to be in the same forest because we'll have automatically built in here a two-way implicit trust relationship. And we'll be able to access resources back and forth between these two domains the same way that these two domains are also able to exchange resources. And in fact, I can even use this domain to access resources down in this domain. So we have trust relationships all the way around here, and we don't have to manually create any trust relationships. And this would be what we call a forest, when I have a totally separate domain namespace here, and yet I still have the implicit trust relationships all the way around. Now, another thing to think about here is that I don't technically need to have a child domain to have a tree. I don't also need to have another namespace to have a forest. I explained it that way just because that's generally how you'll see it documented, and that's generally how people understand this. However, what if I created only nuggetlab.com and I never created any child or other namespaces over here? This is just all I had. Well, that would still be a tree. It's just that the tree would be limited to a single domain. I guess you could call this more like a stump in that case. On the other hand, it's also, if I create only this one domain, it's also its own forest. It's just that we've only decided to create one domain in this forest and one domain in this tree. And from that perspective, another way to think of a forest is any chain of implicit trust relationships. So that if I never created this domain over here, we never decided to go this far, we just have this parent and this child, then that would still be a forest. It's a tree, and it's also a forest, because it's a chain of implicit trust relationships right here. Now, finally, let's also address what a site is. A site is going to be one or more IP subnets that have high-speed connectivity to one another and reliable connectivity to one another. And if you have all of that going on among your subnets, you'll probably create a single site out of that. So, for example, if we go ahead and take a look at some sites here, in Phoenix, we might have 4 subnets. Doesn't really matter. It might be one subnet, might be 4 subnets. But all of these subnets on my local LAN up here in Phoenix for nuggetlab.com are high speed. They're probably 100 megabit per second, and they're reliable. Now, I also have another location here in Tucson. Here I might have 3 subnets, and they're also high speed and well connected to one another and reliable. Now, I'd use the term high speed a couple of times there. How do you know what a high-speed network is? Is it a megabit per second, a gigabit per second, 100 megabits per second? What is it? Well, according to Microsoft's definition of a high speed, they consider anything to be 512 kilobits per second or faster to be a high-speed network, and you should also have at least 128 kilobits per second of available bandwidth. 128 kilobits per second of available bandwidth means that after you've already served your normal network traffic, you should still have about 128 kilobits per second on average available for additional traffic. Now, these two areas of high-speed connectivity then can be separated by a slower WAN link, in this case 128 kilobits per second. Now, WAN links are generally slower as well as less reliable. And the fact that I have a slow connection between these two physical sites will pretty much dictate that I'm going to make this an Active Directory site, and then I'm going to also make this an Active Directory site, so I have the Phoenix and Tucson Active Directory sites. And a good reason for dividing those into two sites is that I can then control the replication across this WAN link, and I can schedule that, and I can make it not replicate quite as frequently as I might have within a single site like I would have up here in Phoenix. And we'll see later on in another nugget that that makes our replication traffic more efficient. In this nugget, we took an introductory look at Active Directory to lay the groundwork for our future nuggets. We took a look at several of the features of Active Directory so that you can see how, as an administrator, they can really help you out and how it can make your network more efficient. We also took a look at the actual Active Directory files themselves just so that we could kind of get a granular look at what Active Directory really is. And we also took a look at the Active Directory structure, again to lay the groundwork for future nuggets, because in our next nugget, we're going to actually install domain controllers. It might be useful to know what an actual domain is, also to know what a tree is, what a forest is, an organizational unit, as well as to know what a site is, which becomes much more important when we talk about replication later on in this series. I hope this has been informative for you, and I'd like to thank you for viewing.